All right, and so the question that you have is actually very similar to a question that a lot of students have um, in how to do a confidence interval in Excel. Remind me, did you have an undergraduate class in statistics?
Yes, but that was like 3 to 4 years ago.
Okay, all right, no problem at all. I took a number of grad classes and undergraduate classes in statistics, and it seemed like a semester later, a year later, I forgot almost all of it. It's something that you have to practice over time. So let's quickly go back over some basics of confidence interval, and then I'm going to walk you through how to do it in Excel. Okay. Um, so our homework assignment for this week is asking you to develop confidence intervals around some kind of a sample parameter, sample data. And then we have to then I develop that confidence interval to say, all right, what would be the true mean if we were to extrapolate to a population parameter? So let's look at an example here, okay? So let's say that you kind of work in hospitality and fan engagement for a minor league hockey team, and your boss comes to you and says, "Hey, we want to know, we're going to give a card to all, to a bunch of families of four, and we want to know how much they're spending in concessions." Okay. That information might be helpful because maybe they're trying to discount package tickets, for a family of four. And if they discount it a little bit to this, do they end up spending this much more in concessions? Okay, so kind of a real world problem. All right, we want to know how much families are spending. All right, well, we have some sample data over here, and I realize that your question is not descriptive statistics, but we can easily calculate this. You don't have any questions on that, right?
No,
But
sir.
to eventually get to our next step, we need to calculate some basic descriptive statistics like our mean, our standard deviation. We might want to know minimum and maximum. Other assignments have asked for quartiles. So all this is pretty basic. So what we're going to take from this, you could go back to your boss and say, if your boss asks you, how the average family, how much are they spending? I'll put you on the spot for a moment. What do you think is the correct answer here? What do you think the average family is spending in concessions? This
Um,
data that we collected.
Probably say mm,
It's our
as a,
what
as a whole,
as a whole. I mean, it's
like
our
the mean, so 29.
yeah, you're exactly right. Yeah, it's not a trick, but you could go back to your boss and say, okay, we took a sample of people that came to the game, and we came up with this sample statistic. The mean, or another I name for the mean, is the average. All right. It's one average, but it's $29. All right, great. You go tell your boss 29 bucks. But that's a sample, right? That might not be all families of four. Or what about other games, other home games? So we want to know, I mean, how sure are we in that sample statistic? So that's going to lead us to our next question. We want to calculate a confidence interval. Either we want to calculate a confidence interval around that mean. Okay. And so visually, here's what this is going to allow us to do. All right. I wrote out some notes for an undergraduate class and took some screenshots. So here's what this looks like. We have a sample and we had 13 in the sample and we came up with an average of $29. But we're then trying to extrapolate to the population, all home games. What's the true average? Okay. So we could, measure and all families of four at every single home game, but that's pretty tedious, right? I mean, that's going to take a lot of effort to follow all families of four at every home game, or statistics can help us. So that's where the confidence interval is going to come in. And visually, what that is right here. It's going to give us a bandwidth around that mean. Okay. So imagine our mean here is 29, and we want to be 95% sure. So we're going to get a lower limit and an upper limit. Well, how do we do that? Okay. We and there's a formula for confidence interval. You actually started doing this in Excel a few minutes ago when you showed me um, your assignment, but I'm going to show you each step along the way. Okay. But let me first just point out here what our formula is. Okay. This is essentially it. I'll show you the dirty version and how I wrote it out, and then over here in a moment, in a graphic of it. So it's an observed statistic. Our observed statistic, it's 29. And then it's going to be plus and minus some degree of margin of error. Okay. Well, how do we calculate that margin of error? There's actually two values we need to come up with. Now, right now, this might sound like gibberish, but again, I'm going to walk you through this, and then you're going to go back and be able to watch this and be like, oh, okay, that makes more sense. We have an observed statistic, and then we're going to be able to plus and minus and to be able to get an upper limit and lower limit. How do we come up with that bandwidth? Well, it's a margin of error, which is made up of our standard error and a confidence level. And we're going to multiply those together in order to get this margin of error. Now, it looks somewhat complicated, but when we break the formula down, it's kind of sequential step by step, okay? We do need to know how to calculate standard error, which is our standard deviation divided by the square root of n, all right? So here's what that looks like. Our confidence interval is a bandwidth on the lower end right here to an upper end. It's our observed statistic, in this case, minus our margin of error. On the upper end, it's our observed statistic plus our margin of error. So let's walk through in Excel how we do that, all right? And if you have questions, ask me to slow down and we can easily go over it. So I've already calculated that here, but I'm going to show you how I do it, all right? So there's a few things we need to know, all right? We need to know how many's in our sample. Okay, we could easily just do a count if function. So, or sorry, just a count function, count. Let's say this was a really big data set, which it's not. I could just easily count and we get 13. Okay. Another value that I need to know is what's called degrees of freedom. Okay. Write down degrees of freedom. Degrees of freedom is it's a common value in many statistical analyses that accounts for some degree of error. Because we're working with sample data, we can't ever be 100% sure in our data. So in this case, the formula for degrees of freedom is just n minus 1. N minus 1. And n is what? How many are in our sample? So I'll blow this up a little bit more so it's a little bit easier to see. Another thing that we need to know was our sample mean. We've already calculated that. Do you remember that 29 that we calculated our average in Excel? Very good. We also need to calculate the standard deviation. And we've been doing this already in the class. So we write our formula. We use the find standard deviation function, and you should come up with for this sample 13.27. Now we're going to start getting into the nitty gritty with the formula. If we go back up here to our formula, we had our observed statistic. The next thing that we need to calculate is our standard error. The standard error was the standard deviation divided by what?
Divided by n.
But the square root
of n, yeah.
Yes. So we've already calculated the square root, sorry, the standard deviation, and we already know n. We just need to write a formula for that. So I'll show you how I did that. So standard error, if you're following this up here, it was just standard deviation. So I just created a function, wrote a formula for it. So it's the standard deviation, and I can redo this. Go here, delete, equals standard deviation divided by the formula for square root is just SQRT. So you could say the square root of what? You got to put it in
13.
parentheses of what?
13.
You're exactly right. Close parentheses. So you see how I wrote that formula? And you'll be able to go back and watch this. And you should get 3.68. Now that's my standard error, okay? So let's go back up. We keep going back up here. We have our observed statistic. We just calculated standard error. And now we need to know a very specific number. It's a confidence level. Okay. We can get this from a standardized chart, or I'm going to show you two ways. I'm going to show you how to look this up in a chart, and I'm going to show you how to calculate it in Excel. But both are going to make I'm just a couple of steps. In order to get that confidence level, okay, this is actually the number that we want, this 2.179. Well, we can calculate that in Excel, but I want you to know where it comes from. It's from a T table. Okay. A T table, and I can pull that up right here. A critical values of T table. So you see all these numbers up here, and then across the rows, and then our degrees of freedom in the left-hand column. We need to know two values. The question asked us what? How confident do we want to be? 95%. You remember on the assignment, it's asking you to, develop confidence intervals for what? 50%, 90%, and 95.
No, yeah,
Yep.
yeah.
Yep. So we need to know how confident do we want to be. In this case, it's asking us to be 95% confident, right? So a confidence level of 95 is equal to 0.05, an alpha of 0.05. How did I get that? So it's just 1, if you see up here, 1 minus the confidence level. If I gave you, let's say I wanted it to be 0.90, 90%. 1 minus 0.1 is 0.9. That's what if I asked you to be 50% confident? 0.1 minus 0.5 is 0.5. Okay. So on your assignment, it's actually going to ask you to do it all three ways. And you're going to see what that does to the bandwidth, to that confidence level around the mean. So in this case, we had a confidence level of 0.95. And then, so what's the alpha? 0.05. There's actually two numbers that we need in order to figure out on this critical values of T. How does Excel calculating this 2.179? It's using our alpha level, 0.05, and our degrees of freedom. Okay. So I'm going to show you how to get there. So on that critical values of T table, we almost always use a two-tailed test. Write that down. Two-tailed test. Almost always. The short answer for that is, remember up here when we were calculating a bandwidth, that bandwidth is both on the upper end and the lower end, not just the lower and not just the upper, it's both. We want a bandwidth on either side. So we want to know, we want to know if something's an outlier over here or an outlier on the upper end. So we use what's called two-tailed. And it gave it at a 0.05, correct? An alpha of 0.05. So we go down the 0.05 column and over at 12, if you're following me, 12 degrees of freedom. And at the point that those two intersect, what's that number?
2.179.
You're exactly right. You're exactly right. So you could do that the long way. And when I do this with students and they have to calculate this out by hand, that's what they would have to do. But Excel does this with a formula. And here's your formula. It's T inverse. TINV. TINV. So what is that? What is it asking for? Well, let me go back here. So let me say equals T inverse. It's asking for a probability level. My probability level is 0.05, comma, and degrees of freedom, 12. Close parentheses, enter. And that's going to give you your T upper. Don't worry about it in this class. And other stats classes, we'll get into T upper, T lower. But for our specific class right now, we're calling this a T upper. All that is, remember back to the formula, it's a confidence level. It's the last key, it's the last piece to our puzzle. And now we can start solving this formula. Observed statistic plus or minus some margin of error. Once we figure out that margin of error, we can add that and subtract that from our observed statistic. It's kind of wordy. So what is that margin of error? Well, we're going to multiply two values. We're going to multiply our confidence level, and we're going to multiply that against our standard error. So how did I get 8.02? I took my confidence level times standard error equals $8.02. You see? So now that $8.02, I just need to add that and subtract that from what? My mean. My mean. So how did I do that? I took my mean minus 8.02, and I took the mean plus 8.02. See that? So now what does that mean? It's all good and well to calculate it, but you got to know what it means, right? So we could write that out. My confidence interval is actually 20, writing out the formula here, 29 plus or minus that margin of error. This was my margin of error. Once I solve this, you get 8.0213 long. So $29 plus $8.02. So on the low end, that's $20.98. And on the upper end, $37. So what does that mean? So when a family of four comes in, based on statistical probability, we are 95% confident that families of four are spending somewhere between $20.98 and $37.02. It's all good and well to say they're spending $29, but we didn't measure all families of four, right? We also didn't measure every single game. If we took a sample of 13 families at one game, 13 at another, 13 at another, 13 at another, we would get much, 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 much closer to the true mean, right? Does that make sense?
Yes, sir.
We can also develop this bandwidth. So that's oftentimes when you see, for example, when you're going into an election, when they say, okay, candidate X we're projecting them to get 46% of the votes plus or minus 3.5%. They're giving a bandwidth around that. What was the number? Did I say 46? They're giving a bandwidth around 46. It's a margin of error. Does that make sense?
Yes, sir.
So that's kind of the steps that you would take to calculate a confidence interval around a sample statistic. I know that's pretty quick to go through that. So let me pause. What questions do you have? I know you'll be able to go back and watch it again, but what live in the moment questions do you have?
I don't really have any other than after you just showed me how to work out for the question I did have.
Yep.
Because you do it step by step for each one, so I have an understanding of how to do it now.
Very good. Very good. Okay. Yes. So if that's kind of making sense, then, when you go back and try to do it on your own, that's kind of how I learned. I would watch somebody do do an example. I would try to follow along and do it just like they're doing. And then you go and try to work the homework. So what I'm going to do when I post this, I'm going to actually post my Excel spreadsheet. But I'm not going to have the problems worked out. Okay. I'll include all of this, but I'll just remove all the formulas and content. And then you can go through if you wanted, you could go back and watch this video and do it step by step as I'm doing it. And then by doing that practice, then I think you're going to be much closer to be able to complete the homework. How does that sound to you?
That's fine.
Okay. Well, very good. Well, if you don't have other questions right now, then yeah, I'll go ahead and start saving this video and get ready to post it for y'all.
Okay, thank you.
Sound good?
Yes, sir.
All right. Very, very nice job. Very good question. I think that's really going to help some other people, buddy.
Thank you.
All right. Take care.
You too.
All right. Bye.